Citizen, you have entered cardiac arrest and administering medical treatment. Subject has sustained multiple grievous injuries. Citizen, you require immediate medical attention. Commencing full bone reconstruction.
What's up, hackers? Welcome to Saturday Hacker Day, the combined red team, blue team stream where we get up to both offensive and defensive cybersecurity. My name is Taggart, and today, as always, before we get into our main material, we're going to cover some of the week's news. So, right off the top of the bat, we have to talk about Proxy Not Shell again. Because it turns out that the mitigations that Microsoft put in place for this issue were incomplete. At least twice, I think maybe 3 times, because of the string filtering that they were trying to do to prevent the specific URL that attackers were using to exploit the vulnerability could be bypassed. So the Hacker News has a pretty solid update on this. But the truth is that if you want the latest and greatest on this, as always, you should be following Go See the Dog or Kevin Beaumont on Twitter. Nevertheless, this link that I'm just putting in chat right now is going to help you out if you are responsible for any of these mitigations. As always, I strongly recommend that if you are operating Exchange servers on the internet, stop doing that. Stop paying extra money for this legacy software. Use Exchange Online. Let Microsoft handle some of that technical debt for you. And if you are running Exchange servers internally, still make sure that these mitigations are in place. In addition to the manual workarounds that Microsoft is listing here, you can also use a PowerShell script that has finally been updated, even though there are no indications that it's been updated, right here to sort of automatically apply the correct URL filtering to your server. So you can have that going on as well. Sneaky Gamer, good to see you. Moving right along. We have to talk briefly about this story that's been making the rounds about a sentence for the former Chief Information Security Officer for Uber. Now, this is not about the recent hack. Instead, this is about a hack from 2016. And the Uber Chief Security Officer, Joseph Sullivan, has been found guilty in a U.S. federal court of not disclosing a 2016 breach of customer and driver records that were disclosed, that were dumped, and also held for ransom. So the specific charges that Sullivan's been found guilty of are important here, because I think that a lot of, by the way, I'm not a lawyer, right? So nothing here is legal advice, but we've been seeing a lot of people saying, oh, this is bad news for CISOs. I mean, not really, is my take. Don't do crimes. That's the take that I have if you're a Chief Information Security Officer. So the two counts are, one, obstructing justice by not reporting the incident. So don't do that. And another count for something called misprision. And misprision is one of those terms you got to go look up in like the Black's Law dictionary to find out what exactly it is. So misprision is the withholding of information related to a crime. So it's not really like it's separate from obstruction of justice, right? This is specific withholding of information. With obstruction can be many different things, but misprision is a specific omission. So at any rate, what actually took place, right, is that he tried to pay off the attackers to prevent them from disclosing the breach. Don't do that. Report the breach appropriately, right? Quotes from the U.S. Attorney say, we expect... so it goes like this. Technology companies in the Northern District of California collect and store vast amounts of data from users. Yeah. We expect those companies to protect that data and to alert customers and appropriate authorities when such data is stolen by, they say hackers, I would prefer attackers or criminals. Sullivan affirmatively worked to hide the data breach from the Federal Trade Commission and took steps to prevent the hackers from being caught. So basically he tried to put it through a bug bounty program rather than disclosing the breach. So don't do that. That was the issue. There was a breach that was a criminal activity first. It wasn't within the confines of a bug bounty program. And then they tried to sort of retcon it into a bug bounty program. Don't do that. Okay. Enough on that. Another bit of comeuppance this week is a sentence for a former member of the NetWalker ransomware group, who was a Canadian government worker. Sébastien Vachon Desjardins of Gatineau, Quebec, was also ordered to pay, was sentenced to 20 years in prison for attacks from the NetWalker ransomware group, and also ordered to pay back 21.5 million US dollars. Given that NetWalker attacked at least 2 hospitals that I know of, and I think more than that. I am 100% fine with this sentence. I am all for extremely strident consequences for going after public sector, especially. Yeah, I think that the register actually calls them scumbags. Yeah, the register headline says Netwalker ransomware scumbag jailed. And yeah, this is absolutely the dregs of humanity. Do not do this. Don't do ransomware in general, but definitely don't go after people who are trying to save lives. So, I am all for these kinds of sentences, and paying back the 21.5 million is really important. You want to impose this kind of cost. You want to make it unappealing. You want the risk of executing ransomware to be unattractively high for attackers. Right now it isn't, but you want it to be. And I think we have... No, that was our last story. Okay, so we're finally ready to move into our main material. Now, if you've been following this stream for a little bit, you know that we've been using Proxmox as our home lab environment, and we have plenty of content out there about how to set up Proxmox, how to get home labs going in general for different kinds of environments. We've done Active Directory, we've done pen testing, we've done web app stuff, we've done Docker, all of these things right inside of Proxmox. But today we're going to do something a little bit special, which is building a malware analysis lab inside of Proxmox. Why is that special? Well, when you're working with malware, you have to take extra steps to make sure that you're doing so safely. My friend Husky is, of course, the author of the Practical Malware Analysis of Triage course, and he goes into great detail about how to responsibly set these kinds of things up. Now, his environment is local, right, using VirtualBox to do so. Getting some questions about where is this content. It is on YouTube. I cross-stream to YouTube to make sure that all these videos are saved in posterity. Just look for Home Lab or Proxmox in my channel. There is also a Home Lab playlist, I believe. So we're going to take that idea and sprinkle a little DevOps dust on it. So what we're going to do today is we're going to demonstrate how to set up a lab in Proxmox and automate the provisioning of your assets with Terraform and Ansible. So without further ado, let's jump right in. All right, got some tunes going. And let's close the news articles. All right, so let's talk a little bit about our environment to start. For those of you who are new to Proxmox, it is a hypervisor. It is a type 1 hypervisor running on top of QEMU. Technique, good to see you. And I have this thing running on not an insignificant machine. This thing is running on, let me go to Starbase. Starbase is an HP ProLiant DL380P. It is stocked with 2 sockets worth of Intel Xeon E5 2670s. It is rocking 64 gigs of RAM, and it has just about a terabyte of RAID 1 storage. So I can expand that if necessary. It's an enterprise server. It actually isn't that power hungry, believe it or not, but I don't leave it running all the time. I only turn this thing on when I need it. And so, as you can see, I have the capacity to run quite a few machines at once. Now, in full transparency, this whole rig cost me around $425, and I picked it up from SaveMyServer.com, and it shipped in a few days. I have an extended warranty for it. I was really happy with that whole process. Now, the rig itself cost me $425, and then add another like $130 on top of that for the uninterruptible power supply that I have that thing connected to, and that's essentially my home lab. That's it. Everything that I need to do from a home lab perspective can run inside of Proxmox. Setting it up was super easy. Yes, I got it with the HP ILO license so that if I ever lose connection to the hypervisor, I can connect to the machine remotely as well. So from a setup standpoint, yeah, it's a little bit more than just running VirtualBox or VMware Workstation or something like that. But what I get on top of that is a lot of DevOps power. Now, somebody might be asking, why didn't you use, VMware? First of all, I don't like VMware at all. And second, without paying for a proper VMware license, I wouldn't have access to the API to provision machines programmatically. And that's what I really wanted to do. I am a huge proponent of open source software. Proxmox is that, therefore, Proxmox. So Proxmox has an API that you can hook into, and it also has a published Terraform provider. If you're not familiar with Terraform, it is a way to automatically provision assets in the cloud. And Terraform is cool because it is cloud agnostic. There are providers for any multiple kinds of resources, whether it's AWS, Azure, Proxmox, ESXi. Take your pick. Terraform probably has a provider for it. And for that reason, you can build Terraform plans that allow you to set up these labs programmatically to find what you want. So let me show you what one of those plans looks like for our malware lab situation. I'm gonna close some of this stuff. Let me close all these tabs. Oh, Technique, you're right. I gotta change my Chiron, my bad. Thank you very much for that. Good looking out. Thanks, bud. Okay. So let's open this up. By the way, if you want to see all of this code, guess what? It is open source. Now, it's still a work in progress, but if you want to check it out, you go to this repo and make sure you switch to the Proxmox branch. And almost all of this is going to be up there for you. Certainly all the roles and the Terraform playbooks that we're going to be talking about today. And the Ansible... Sorry, the Terraform plans and the Ansible playbooks that we're going to be talking about today. So let's look at Terraform, and here's Malware Lab. So we'll start by looking at the main Terraform right here. So what this is doing is defining kind of the global stuff that we need. So I have Terraform provided right here. This is the provider definition. And then I'm setting up some variables that I'm going to use inside of my other plan TF files. And the way that Terraform kind of works is you kind of just toss all the .tf files into a single folder, and you say Terraform plan, and it figures it out, saying what requires what, and kind of makes the graph of dependencies for you. So you don't have to usually manually say or explicitly say, I need this to come up before this if you have resources defined in different files. It will figure out what is required to set up in sequence. So we have a username, we have a password. Now this stuff is set up for my environment. You can set these to whatever you want. And then if we go to the rest of our machines, let's talk about what the malware lab shape is going to be just broadly before we go too far. So we're going to be talking about 4 machines here. The primary machine is going to be our data collection server, and this is going to be an ELK server. It's Ubuntu 2204, and we're going to install the Elastic Stack on it. And I have an Ansible playbook. Actually, I have an Ansible role that automates that entire thing. Could you increase the font? Yeah, it's already like pretty big, but you can also, look at it in full screen. Now, in addition to the ELK server, we're going to deal with 3 other machines. One is I'm going to set up a Kali machine, and I'm going to tell you why. I actually prefer Kali as an analysis platform for Linux as opposed to Remnux, which is what Husky uses in his environment and what many people like. I don't like Remnux. I don't like the way that it's built. I don't like the way the tools are organized. It just doesn't feel very ergonomic to me. Your mileage may vary, and I actually have some stuff in here about Remnux to set it up for not this lab, and you're welcome to play with that. But I prefer Kali. It's the environment. It's one of the Linux environments I spend the most time in, and a lot of the defensive, the malware analysis tools that I need are in fact available in the Kali repos anyway. So, and I already have a Kali template, right? So I'm just going to use that. So that's my Linux analysis machine, basically. And if I ever need to do HTTP proxying with Zap, I can do that really easily too. Then I have two Windows machines. They're both Windows workstations. One is going to be for the victim. This is the machine that we are going to sacrifice up to whatever malware. And then we're also going to set up a malware analysis machine with Windows. And because there are some things that you just need a Windows machine to analyze, right? If you want to do live debugging of a piece of malware, you're going to need to have something like that, or static analysis, anything like that. You want to have an analysis machine. Now we're going to install the same tools basically on both the victim and the analysis machine, so we can use them somewhat interchangeably. But the idea of having kind of a sacrificial lamb that we will snapshot and then kind of reset to a known good state as we go is the idea behind the analysis machine. We'll talk about isolation for the network in just a minute, but this is the basic idea. So we have these different machines. So if we look at the Kali, it's very, very simple. And all we're doing is some basic provisioning once we create the VM. Terraform is not doing all the installation of packages or anything like that. That's not really Terraform's job. Like, you can do it technically, but don't do it with Terraform. That's really not its job. Its job is to bring assets up. And that's exactly what it's going to do for us. It's going to bring the assets up. Once they're up, we are going to use Ansible to configure the machines to our satisfaction. Now, you could use Puppet or Chef or whatever else you wanted. I like using Ansible basically because it's Python. It's something I'm familiar with. And I will mention, if you're new to this channel, all of our machines that get spun up in the lab, all of our templates have SSH enabled. Yes, even the Windows machines. So I don't have to futz with PS remoting. I don't have to futz with WinRM. My administration of all of my Windows assets is done over SSH the exact same way as I would do it with Linux, which means that I can use Ansible essentially the same way for both sides of the house. All right, so we have a Kali machine. If we look at the Win analysis machine, they look very similar. You'll also notice that one of the items I have here, in addition to setting up things like CPU cores and the amount of memory, is this key called pool. And this is kind of neat. In Proxmox, we can have this thing called a resource pool. And it just makes it really easy to look at the specific VMs in that particular group. So that's a neat trick that we're going to use. We're going to kind of use a lot of Proxmox bells and whistles today, and this is one of them. Hey, so some follows to thank. Emma, thank you so much for the follow. Maître Bonobo, bienvenue. Twitch Creep, thank you so much. And of course, Valhard, friend from the Discord, welcome. Now, once the Proxmox machines, but once Terraform spins up the machines in Proxmox, there's this output block. And what this is going to do is report home the IP addresses of the things we just spun up. That's going to matter a lot for what we do, because I'm going to add some stuff into my etc hosts file on my jump box here, my Ansible server. And I'm going to set some stuff up in my Ansible playbooks as well based on those IPs. So all of my VMs are reporting home their IP, and they're doing so with the agent. You know what? I'm going to disable the Kali machine for right now, because I don't think we're going to need it. And I forgot to install the agent. Okay, we'll just call it tf.back for now. So we're just gonna spin up ELK, the Win analysis, and the Win victim, nice and quick. So here we are in our Terraform. I'll try to increase the font a little bit to make that a little bit more readable for folks. And I've already run this thing called alias, which I'm setting TF as my alias for Terraform, because Terraform's really long and I don't feel like typing all those keys. So we're just gonna do TF apply -auto approve. Now, I also have some environment variables set that you're not seeing. And those environment variables are my API user and my API key that allow Terraform to connect to my Proxmox server correctly. Okay, so as you can see, the plan has been approved, and now it's connecting to Proxmox, and it's spinning up these assets. If we go over to Proxmox, you'll see in just a second that, oh, there they are. Malware Lab, Win Analysis, Win Victim, and ELK are coming up for us. Hey, Technique, thank you so much for 6 months of continuous subscription and 8 months total. Really appreciate that, my friend. Now, it doesn't take too long for these machines to spin up, but while we're doing so, let's talk about, while we're waiting for them to come up, let's talk about the next steps. Okay, so if we look at our Ansible playbooks, much of what we're going to be doing is set up in roles. So I have a bunch of different roles configured, and these are things that you can call, you can reference in playbooks, so they're predefined steps to assign to any given set of assets. So one of them is ELK stack, and this is going to be kind of the biggest move, and it's the first one that we have to do. We have to set up the ELK stack first before we set up the analysis machines. The reason being, we're going to be installing the Elastic agent on our machines, but they need to have a fleet server to phone home to before we do so. So we set up the ELK stack and the fleet server stuff on our primary Ubuntu server first, and then we go set up our analysis machines. So it's not totally hands-off, but it's pretty hands-off. All right, let's take a look at the tasks that our ELK stack will be undertaking. This is a pretty long playbook or set of tasks, to be honest with you, and I'm not going to lie, it took me a long time to automate this to my satisfaction so that it would work out of the box every time. And some of it you have to kind of work against what would be considered best practice from Elastic or from other sources when you read these instructions to get it to work with Ansible. But it does work at the end of the day. So the first thing that we're doing is we're adding Elastic's GPG key, allowing us to use that GPG key to sign repositories. And so you can see that's happening here. And I can't use the, Ansible has a built-in apt repository plugin, but I can't use it because of the way that these keys are getting added now. They've deprecated apt key add, which is the way that you used to do this, to add GPG keys to sign repositories. So now, this is the way that you're supposed to do it. You download the binary GPG key. I'm sorry, the armored, so base64 encoded GPG key. You pass it to GPG dearmor, which creates a binary version of it. And then you send it to this keyring file, user share keyrings, Elasticsearch keyring. Once you have that file available, you can then create apt sources that are signed by that key. And that's what we're doing here. We're signing by this keyring key, and we're adding the Elastic source. Stable main is all good. And then file name elasticate, state present. And then we don't update the cache in this case because we're about to do it here. And this is where we go install Elasticsearch. And then we enable it with the systemd because it's already set up for us. We then reset the Elastic user password. So when Elastic installs, it creates a user password for the Elastic user, and that's the first, like the super user you have to log in with first. Problem is, you won't see it if you do it automatically. So instead, we call this reset command, right, that is set in user share Elasticsearch bin, and we send it a Y to confirm it. And what we're doing is we're registering a variable that allows us to collect the output of the command and show it later on. We have a notify here, which will kick off a handler in Ansible parlance, and we'll see the handlers over here. So all of the handlers will happen after the tasks have run. We then install Kibana, which is available now from the Elastic repos. We're doing this little replacement here because by default Kibana is not accessible outside of localhost, but I need to get to it from my jump box or wherever else, right? So I am replacing that line in the etc kibana.yaml file, right? I'm looking for this server.host configuration with the commented out line here, and I'm replacing it with exactly what I want it to be, which is server.host and then 000 in quotes. You could add your IP if you wanted to, but in this case, we're just allowing it to listen across all interfaces. Then we're going to create the Kibana enrollment token. When you first log into Elastic, the next thing you're going to need in order for Elasticsearch and Kibana to play nicely together is this enrollment token. So again, we're running this to get the enrollment token for the service Kibana, and we're registering that value, and then we're going to notify. We're going to print that out when the playbook is finished. We enable Kibana, and then we install the Elastic agent, and we enable that systemd service. So that's the last piece that we do, and then we have to configure the fleet server in the actual web interface of Elastic and Kibana. So this is the first thing that takes place. Let's take a look at our VMs. Awesome. Looks like they're up and running. Let's take a look at Terraform. Terraform has reported our IPs for us. I love when a plan comes together. So the first thing I'm going to do here is I'm going to vim Etsy hosts. And you can see I have these listed already. Of course, I tested this before we did it live. I've learned my lesson on that front, but we're going to replace some of these. So analysis is 85 and win victim IP is 188. In case anybody's wondering, DHCP addresses are getting assigned by our router, which is the SecLab router right here, which is an OPN sense router. And I just have that assigning DHCP to two different subnets that I have in here, one for infrastructure and one for our experimental lab, which is where these things live. All right, 185, 188, that looks good. I'm then going to remove the Malware Lab ELK right here. And I'm going to re-add it. So SecLab is... Oh, nope, that's good, that's good. Let's confirm that I can connect to it over SSH. Indeed, I can. Awesome. Okay, we are now ready, except that we have to take our ELK IP, 99.158, and we're going to modify our ELK stack playbook here and have it run on... Oh, my bad. No, I don't. I have Malware Lab machines, right? And the reason that I need the ELK IP is for some of the tasks. Actually, I don't think I need this for the sim. I'll leave that right off. But see how it is hosts Malware Lab ELK? This does matter. And the reason I can use this host name is not just because I added it to my Etsy hosts, but because I'm using Ansible's inventory. And this is the inventory file that I will be using. You can see that I have some Linux hosts, and I've added Malware Lab ELK and Kali to the Linux hosts, and I've configured that stuff there. And the Windows hosts, I have the Win Analysis and the Win Victim. So I have those set up in my inventory, which means when I run Ansible, which I will do from over here, I can just run Ansible playbook -i inventory.yaml to point it to the right inventory file, and then malware lab sim.yaml, and that will be the playbook that it runs. And that's exactly what I want it to do. So I will kick this off. It's finding the right host, which we've now configured with Etsy host. It is able to connect to it, and it's just running the playbook straight ahead. I'll mention, of course, that if anybody has any questions as we go, please don't hesitate to ask. The mission of this channel is to educate about these maybe not so simple things, but they're pretty cool once you're able to pull them off. Valankar, thank you so much for the follow, and Space Ghost 7, as well as Mr. Dante. Appreciate all those follows. All right, while this playbook is running, let's take a look at what has to happen for our machines and how these are configured, because this is a little bit different. So for the Malware Lab machines, I have hosts set up here, Malware Lab Kali, Win Victim, and Win Analysis. Kali will be off the table for now, but that is okay. Now, the important thing to know is that this shall not be run until we have the fleet server set up. You have to do that first. And the reason you have to do that first is because the installation of the Elastic Agent requires this information. Not only the IP, but also the fleet server token that we will be using to make this happen. So we have the SecLab Kali role, which we won't be firing off because we're not going to use the Malware Lab Kali machine. We'll just set it up to win victim and win analysis for right now. And then we have, let's see, we have the malware analysis Linux. Again, that would be for Kali. We'll take a look at the role to see what it does. And then we have the Elastic Agent going on both machines and the analysis stuff going on both machines. And then finally, we're installing Sysmon because of course we are. We need that Sysmon data. So if we take a look at the malware analysis Linux playbook or tasks, actually not that crazy. Basically, we're installing ZA proxy. If it's not there, it should be. But we're also installing the forensics extra package, which has a lot of cool stuff like XIF tool that we may need for looking at some files. And then XRDP so that we can easily remote into the machine. We're also going to set up Cutter, which is my disassembler of choice. And easily enough, we're just getting it from GitHub and we're putting it right inside of scripts. And then we're installing OLE tools, Stego Veritas, and then we're making sure that XRDP is enabled. That's kind of it. Now, you can modify this to whatever else you want. If you wanted to install other packages, if you wanted to add Ghidra or whatever else you were interested in, have at it. Right? This is meant to be modified by you. In fact, that's why this repo is set up this way. I'm building all of my stuff in the examples folder. But there is another folder inside here called My Playbooks, which is designed specifically for you to run. And none of those are tracked by Git by default. So you won't mess, you can Git pull and not mess with anything if you make changes in there. That's totally fine. So that's the Linux side of the house. Let's take a look at what happens on the Windows side. Now, this is probably my favorite part, honestly. And here's why. If you follow through Husky's course, and I'm not trying to ding on him, like, it's a fantastic course. But one tool that he uses and that I've used in the past is Flare VM. If you're not familiar with Flare VM, it's essentially a script from Mandiant that turns any Windows machine into a malware analysis laboratory. Here's the thing about Flare. It's gigantic. It takes hours to run, to configure a Windows host, at least in my experience. It takes a long time to make it run. And once it's done, I find that the Windows machine that I have at the end of the day is a lot slower. Like, I don't know everything that Flare is doing under the hood, but I am not happy with all of it. And the truth is that I don't need everything that Flare is giving me. I really don't. I need a few tools that I'm used to using. And so instead of configuring it with Flare, I'm going to create my own malware analysis machine with the tools that I know that I want. And I'm going to use Chocolatey to do it. Now, there are a lot of different package managers available for Windows. Scoop, Winget now, right? Why am I using Chocolatey? It's probably the oldest of the... It is the oldest of those three. So why am I using Chocolatey? I'm using Chocolatey basically because, one, the Ansible plugin for it is really mature. And two, it has all of the packages that I wanted. That's basically why. So in addition, I can install Windows Terminal. I can install sysinternals, PE Studio, PE Bear, x64 DBG for debugging, Ghidra, and Cutter without having to do anything extra. So all I have to do is configure Chocolatey to install these tools. And Ansible's Chocolatey plugin will first check to see whether Chocolatey is available, and if not, install it for me. So I can just throw this at a brand new VM, and it will install all the tools that I want, and then I'm done. And then the last thing I'm doing is I'm adding the Chocolatey bin files to the path, right? So that I can access all of the stuff that Chocolatey installs. That's it. Not too bad, right? So that's the analysis side of the house. If we look at the Elastic Agent playbook, it's a little bit funkier. 2 reasons to use chocolate. It works. 2, it ain't broke. Yeah, basically. That's it. So for the Elastic Agent, I'm just doing a sanity check on the fleet server token. And then we're running this PowerShell script to make it happen. And this is, you can see, this is where we needed the ELK IP. And this is where we needed the enrollment token. And then everything else that you have going on here, this is I for insecure because you won't have a good cert at this point. And F for force in case it was already installed. Lastly, if we look at the Sysmon installation, you may be interested to see that. It goes a little something like this. We're downloading Sysmon. We are downloading the Swift on security Sysmon config. You could set this up however you want. I'm using the Swift configuration because it's easy. We're installing Sysmon as a service. We are then removing the Sysmon installation files. And that's it. Everything else is sorted for us. And then the Elastic Agent will be configured with a policy that allows us to collect those logs directly into our ELK server. That's it for how these things work. Let's get them built. So let's see. Oh, God, I love it. I love it. So our Elastic password has been set. And we have our Kibana enrollment token. Now that is different than the fleet server token, be aware. Let's start by going to Malware Lab ELK 5601. All right, so Elastic is open and running. Let's get this enrollment token copied. Now, this is one extra step. We have to add the verification code. So to do this, we're going to SSH into the ELK server. I hope. The thing is up. There we go. And we're going to do sudo user share Kibana bin and then Kibana verification code. And that just prints out this verification code, 922838. And we're in. Then we'll need that Elastic password to configure. Gebs asks, do you have any project ideas for Blue Team cybersecurity using C# and .NET Core? Using C# and .NET Core. Well, I can tell you what I'm trying to do without C# and .NET Core. This is something I'm slowly working up to, and you're more than welcome to play with the same idea. Is stuff that looks at the Windows API specifically and try to find a different way of looking at that information besides API hooking to look for malicious activity at kind of low levels. Now, the .NET, using that through .NET may actually prevent you from doing exactly what I'm saying because you're a layer of abstraction higher than the Windows APIs that I'd be going for. But if you do something like pinvoke, then you are kind of getting directly to those DLLs and calling them directly. You could also, just as an idea, I'm just spitballing here, you could probably write something like a monitor for web shells. So one of the things with proxy.shell is that detection of those web shells is difficult for a couple of reasons. One, Defender out of the box, both the free Defender and Defender for Endpoint, by default and by Microsoft recommendation, excludes the web root for IIS, right? So web servers, including the Outlook Web Access that Exchange runs, okay? Those folders are excluded from scanning by Microsoft Defender. So, what you could do is write a tool that analyzes patterns in web shells, tries to find ways that make sense, or even looks for new file writes that would contain indicators that a web shell has been dropped, because that's usually, especially for proxy shell and proxy not shell, it's like the first step. But even vulnerable ASP applications would have this issue as well. Look for those and alert on them some other way, whether it's triggering some sort of ETW, hooking into Defender. I don't really know what's possible there, but finding some other way to monitor beyond what is available. I think that might be a cool experiment. All right, let's log into Elastic. Awesome, we're logged in. We will never use that password again, because the first two things we're going to do, I will explore on my own. First two things we're going to do. Number one, of course, is enable dark mode, which is mystifyingly in advanced settings. So advanced. Ah, much better. Okay, with that out of the way, now we can add users. Right, so I'm just going to add myself as a user. Great. And I'll set up a password here. And my role will be super user. So I can do everything. And that will be how I log in. I love that dark mode is a global setting. Everybody gets dark mode if you set it. Okay, now we're about ready to set up the fleet server. So this is kind of the next part. We're going to go down to management and fleet and get started with fleet server. Hey, Miser9, thank you so much for the follow. And the first thing it's going to do is generate a fleet policy. Now, there's kind of a way to do this from the command line, but I couldn't find a clean way to automate it with Ansible because of kind of the sequencing. So it's 10.1.99.158, port 8220. So that's our fleet server host. That's us right here. We're using what it tells us is the port. And it's going to generate the fleet server policy for us. Now, the steps that Elastic will tell you to take, you don't have to run them exactly this way. We're still SSH'd into our box, which is great news. So here's the deal. You don't have to do all of this. The reason you don't have to do all of this is because we already installed Elastic Agent as part of the Ansible playbook. The only thing you have to do is this last piece right here. But even this is wrong. Okay? Even this is wrong. And the reason it's wrong is because this assumes that you have signed this, you have assigned a proper HTTPS certificate to it. If it's a self-signed cert, then it will fail, which is super annoying. So you actually have to add another command line option to this, which is -- fleet server es insecure. That's different than the insecure command line option we use in the Elastic Agent playbook to set up the agents to phone home to the fleet server. But this is how we set it up to actually configure this. And also, it's not ./elastic agent, it's elastic agent because we installed it globally. Oh, right. And also force. Cannot perform installation as elastic agent is already running from this directory. Come on. Yeah, force should work. And did I get the other command line option right? Fleet server. Yeah, fleet server, ES, and secure. Yeah. Installs the system package, installation will not be altered. Cannot perform installation as elastic agent is already running from this directory. Do I have to stop the service first? That wasn't what I found to be the case last time. Oh no, here we go, here we go, here we go. Sorry. I used the wrong thing. Instead of elastic agent install, it's got to be enroll. And that should work. I've always wondered why ELK stack is such a pain to set up. It's honestly, it's not that bad. All things considered. I'll take it over setting up Splunk. Yeah, so if we use enroll. What did we do wrong? Let's see. And we still have to do fleet, server, ES, insecure. There we go. Okay, so that did work. We just have to use the enroll command as opposed to, so you take the deb instructions and just use the enroll. I'm guessing a sim is too big of a project to do it yourself. I mean, you can try, but yeah, that's a lot. Okay, so by the way, notice that fleet server is connected. It's now working. We are now sorted. So we're going to continue enrolling the elastic agent. If we continue with this, we're going to add a new policy. So we're going to call this the Windows policy. Okay. And we don't actually have to worry about any of this because Ansible is going to do it for us. If we look at our elastic agent, all of this is sorted. So now that we have the elastic agent set up, we can actually run that Ansible playbook right here. So Malware Lab machines, now we're ready to go. But keep in mind, it's going to ask us What? What'd I do wrong? What is happening? That shouldn't be the issue. Oh, no, it says the role malware analysis win was not found. That's the issue. Oh, because it's malware lab. Good job. Excellent. So the first thing that happens is that it asks us for the fleet server token, which is this thing. That's what we need. Okay. And we're going to take that, paste that right in. Boom. Couldn't hit the victim. Oh no, did it power off? No, it's on. Ooh. Let's fix that. Looks like there's something wrong with the name resolution. Vim Etsy hosts. Let's see what I did wrong. Malware lab win victim. This is why all those host names have to be set correctly. Okay. JM Reika asks, do you prefer Splunk or Elastic or something else? It depends on the use case. Elastic is great for this lab stuff because it's free for a lot of really advanced features, and it allows me to get these kinds of labs set up pretty quickly. I use Splunk a lot in my day job, and I like a lot of what Splunk can do. In fact, I like its query capabilities a lot more than I like I find Elastic's querying to be hyper limiting. I really don't enjoy it. Now, I'll also say that I have been quite enjoying my time in Sentinel, right? Azure Sentinel. I really like KQL. I like the way that it handles data, and I've been having a lot of fun with that. In fact, there's a challenge going on right now called the Custo Detective Agency. Yeah, detective.custo.io. Whoa! Ash Fox is raiding with a party of 23. Ash, thank you so much for the raid. Appreciate it. Welcome, new friends. How was your stream? For those of you who just got here, we are setting up a malware analysis lab in Proxmox, and we're doing it with Terraform and Ansible. Hey, Christy. Good to see all of you. But yeah, so a question was just asked, which SIM do I prefer? I like Splunk. Elastic is what we use for the lab because it's free. But yeah, if you want to learn more about KQL, this is kind of awesome. The Custo Detective Agency. It's a set of challenges that I think all 5 of them are released now. They're not easy, but they will teach you a ton about KQL if you're interested. It's pretty well put together. I'm impressed with it, right? So the first thing it does is it teaches you how to create a free custo cluster and use Azure Data Explorer to take a look at it. I think it's pretty rad. We might do all 5 challenges on stream at some point. But yeah. Welcome, Compromise. Everybody's bad at crypto. Don't worry about that. Compromise, everybody is. Except for Duct Tape and Dreams. He's the only one who's good at cryptography. Christy redeemed Play Me a Song. Oh, wow, okay. How long are you sitting on those points? Jeez. All right. We'll do that. So we're going to take a quick break. Let's see how our Ansible playbook is doing. Chocolatey is getting installed. Very cool. Let me bring up our camera here. Okay.
Yeah, so this happens sometimes. Sound check. How we doing? All right. This is a song I've been working on for a little bit. Why do we play with fire? Why do we run our fingers through the flame? Why do we keep our hands on the stove, although we know we're in for some pain? Oh, why do we refuse to hang a light when the streets are dangerous? Why does it take an accident before the truth gets through to us? Cages or wings, which do you prefer? Ask the birds. Fear or love, baby, don't say the answer. Actions speak louder than words. Why should we try to be our best when we can just get by and still gain? Why do we nod our heads although we know the boss is wrong as rain? Why should we blaze a trail when the well-worn path is safe and so inviting? How, as we travel, can we see the dismay and keep from fighting? Cages or wings, which do you prefer? Ask the birds. Fear or love, baby, don't say the answer. Actions speak louder than, louder than, louder than. What does it take to wake up a generation. How can you make someone take off and fly if we don't wake up and shake up the nation? We'll eat the dust of the world, wondering why. Oh, why do we stay with lovers who we know down deep just aren't right? Why would we rather put ourselves through hell than sleep alone at night? Why do we follow leaders who never lead? Why does it take catastrophe to start a revolution if we're so free? Tell me why, someone tell me why so many people bleed. Cages or wings, which do you prefer? Ask the birds. Fear or love, baby, don't say the answer. Actions speak louder than, louder than, louder than, louder than. Cages or wings, which do you prefer? Ask the birds. Fear or love, baby, don't say the answer. Actions speak louder than, louder than, louder than. Actions speak louder than, louder than. Actions speak louder than.
Ready? Okay. Hey, Orbital, good to see ya. Thief of always. Oh, hey, Foot. All right. So, back at it. Chocolatey is still getting installed, I see. So for those of you who are just joining us, we are setting up a malware analysis lab inside of Proxmox. Orbital, I'm so stoked for the Phil's game tonight. If you don't know about Foot, you should go check them out. Probably host of one of the, if not the most active cybersecurity discords out there. All right, so Chocolatey is still running. It's installing these tools, and that's all good. Oh my, Foot, thank you so much for those 5 gift subs to Muskie, to Basic Block, to Neon, Born to Lose, and to Goomba. Incredibly kind of you. All right, so just waiting for this Chocolatey stuff to install. So what are we doing? We're using Chocolatey to install. If we go to the playbook here, we're installing PE Bear, x64DBG, Ghidra, Cutter, PE Studio, FakeNet, which is going to become really handy in a second, Microsoft Windows Terminal, and sysinternals. Now, we can walk through these tools in turn. If you haven't played with PE Bear, I'm a huge fan of Hasherasad's work. PE Bear, I want this on GitHub, not their blog. It is a really, really nice, it's not just a hex editor or hex viewer, it's an analyzer for reversing portable executable files. And I just like the way that it shows stuff. It's for a quick view. It's not as comprehensive as Cutter, and it doesn't have some of the detections that, for example, PE Studio might have. But it is a great way to look at kind of the general breakdown of a portable executable. Very, very handy. So what else do we have going on? We have x64dbg. So this is a live debugger. We could also use WinDBG or Immunity if you prefer. All of those are available inside of Chocolatey, so you could just change those packages out. PE Studio. PE Studio is great for things like looking at a quick signature-based analysis, an indicator-based analysis of a sample of malware. And so it'll analyze for strings, it'll look for potential obfuscation. Really nice first pass tool. And of course, we're using Ghidra and Cutter when we're ready to go a little bit deeper and actually reverse some malware. Phenomenal. So Chocolatey stuff got installed. Choco has been added to the path. And now it is installing the Elastic Agent on our Windows machines. And if we go back over to our fleet here, we should, in due course, see some new agents coming in. It might take a minute for the agent to install. Thief is doing some weekend work on Alpha and Black Cat and Snatch ransomware case watching. Oh, very cool. Very cool indeed. So while we're waiting for these agents to start phoning home, we can talk a little bit about... Oh, that's done. And then Sysmon's coming in. Cool. Hey! And look, they came in. Now they have the same desktop name, which is kind of annoying. We could have changed that up, but we only really need it from the one. We could also have run a sysprep to prevent that from happening. But as you can see, now we have data coming in. Everything looks good. And Sysmon is getting installed as a service. With that done, then, what we can do, you can see these are already set up for the Windows policy, right? Which is our default policy. And then we're going to look for some integrations. And this one's important. So if we go to integrations, these are things that you can add to your Elastic Agent. So if I look for Windows, there's custom Windows event logs, which is cool. But also there's just Windows. And believe it or not, the built-in Windows event log integration will do Sysmon. So all I have to do is add Windows here, and it will pull in those logs. Right? You can even see what logs it's pulling in. So forwarded, PowerShell, PowerShell operational, and Sysmon. Fantastic. Exactly what I want. Where to add this integration, we're going to add it to existing hosts in the Windows policy. Save and continue. Save and deploy changes. And the agents will get that update. We don't have to do anything else. And because Sysmon's already installed on those endpoints, those logs will start coming into our environment basically immediately, as soon as that update is pushed. Now there's an upgrade available. We could try to upgrade the agent. See that? Not too shabby. Now, if you've done any Elastic or ELK work in the past, you may be familiar with getting file beats set up and everything else like that. Here's the thing. That sucks. I do not like working with FileBeat or WinLogBeat. And that's why I like the Elastic Agent so much, because I don't have to. I can have a single agent that is responsible for picking up all of the things that I'm worried about and use these integrations to manage them, rather than having to go in and configure those LogBeat things. And by the way, the Elastic Agent works cross-platform. I can get it for Mac, I can get it for Windows, I can get it for Linux. The Linux stuff is cool too, because there's an audit D plugin. I even have a way of getting sysmon for Linux data coming directly into the SIM as well. So honestly, not that bad from a deployment standpoint. Now that this is all set up, we're pretty much ready to go. Now, the last thing I want to talk about, a couple things we didn't do. We did not set up Zeek or PCAP stuff. We haven't done that yet. And that is something that we can do. That takes a little bit more configuration in Proxmox. We've actually covered that in some previous videos, but we're not going to do that for right now. But what we are going to do is talk about how we would isolate our victim before we detonate malware onto it. Right? That is super important because we don't want to have that information getting out when we don't want it to. So, a couple of words about isolation. For one thing, let's SSH into this thing just to confirm that we can. So, malware win victim. Awesome. So I am in here. I'm SSH'd in. Let's get a PowerShell going. Hey, Owen. Choice, nope. It was a long shot. I'm going to have to fix that path addition because it doesn't seem like it's working. If we look for env path, yeah, it's not there. But the good news is we can add it. So we're going to add plus equals program data chocolatey bin. I don't know why tab auto completion is having such a problem here. There we go. Good God. And let's put that in quotes. See? And now we have access to Choco, but we also have access to all the stuff that it installed, including FakeNet, right? So that is one easy way to get access to that. So in terms of isolation, that's an easy way to do it. So FakeNet, what does FakeNet do? FakeNet will hijack your network configuration and log data as requests are coming in and out. So let's fire up FakeNet briefly on here and demonstrate how that goes. I will go over to Proxmox and go to our victim. You know what? There's one other thing I forgot to do, I think. No, I didn't. No, I didn't, because it should have been part of the template. Just kidding. I can, I believe, RDP into this thing. Let's go 1440 by 900. Yes. Maybe so. Let's make sure remote desktop is enabled. That should have been part of the template. I will... There we go. Take your time. Now, The other thing that we can do, we'll set up FakeNet, but I will quickly mention as this is getting ready, the other thing that we can do is set up the Proxmox Hypervisor to do some firewalling for us. And honestly, this is the best way that I have found to isolate a VM if we really want to make sure nothing is going out that we don't want to go out. It's pretty wild. In order to make this happen, if you're using Proxmox, you have to make sure that the firewall is enabled in 3 different places. So up in the data center level, you got to go to firewall and change and options and change firewall from no to yes. By default is disabled for the entire data center. And if it's disabled anywhere in this chain, it won't work. So turn it on, leave everything else as it is. In your node, in this case Starbase, also make sure that the firewall is enabled. So again, go to options and make sure the firewall is set to yes. Then for any one of your nodes, you want to make sure that your hardware, we only need one network interface. I've kind of redone some of my network design, so I no longer need 2 network interfaces. So you want to make sure that the firewall is enabled on the network interface. Super important. So you want to see firewall equals 1. And then in firewall here, you also want to say firewall is set to yes. Now, here's the trick. The instant I turn this on, the global rules start applying. And the global rules in this case are the input policy is drop and the output policy is accept, meaning that it is global deny into the machine. Okay? Which means my SSH connection may have just died. Or I won't be able to establish a new one. Right? Because incoming traffic is no bueno anymore. So to fix this, I have to add some firewall rules. To do that, I go to firewall and add. And by the way, you can make security groups and all sorts of cool stuff, but just to do it ad hoc here, just to show you. So direction inbound, action accept. We're going to enable the rule, and the macro is SSH. Easy days. And make sure that it's on. We'll add another one for RDP. You can specify IP addresses if you want. You can also define those as IP aliases. Okay, those are both on now. And now I can connect over SSH again. So you kind of see where this is going, right? If I set up firewall rules, if I change the outbound to drop, if I change the default outbound policy to drop, then everything is shut down. It's not going to let anything out. Or I can be more specific, saying no DNS goes out, right? None of the HTTP goes out. I can fully isolate this thing from the hypervisor level, preventing the VM from really doing anything network-wise. So this is a really easy way of making that happen. Let's try this connection again. Boy, it does not want to let me in. One last time. Interesting. Okay. For now, we'll just use the console and see what's up. Yeah, okay. My Windows license will expire soon. I'm not too worried about that. By the way, here's a trick in case you don't know about this. If you ever need to extend an eval license for Windows. Unclear why that just happened. If you ever need to extend it, you can do this, I think, 3 times. So if we search for the command prompt here. Oh my god. Let me run this thing as an administrator. One of the things that you can do, actually, I guess we could have done this from the PowerShell connection as well. In fact, I will, because it's so much more responsive. You can run slmgr.vbs/rearm. And that will reset the counter for the evaluation period. So, fun trick there. Now, let's talk about FakeNet. This is kind of cool. So if we open up our Edge browser right now, we'll get to the internet, no problem. Did I under-resource this thing? 2 CPUs, 4 gigs of RAM. A little. I could have been a little bit nicer about that. Especially since Edge does a bunch of nonsense when you first launch it. By the way, does anybody have any requests for malware to take a look at once we have this thing ready to fire off? Start with out data. Thank you very much. Okay, so obviously I can get to the interwebs. No problem, right? Bing search is working. Now, I'm going to fire up FakeNet. Oh, I have to do the... Stuxnet. If I fire up FakeNet, it'll start running. It's setting DNS settings, it's setting SSL, all this stuff. And now you can see I'm getting data for DNS queries that are getting received, right? If I reload the page now, I get the help file for FakeNet. And I see in PowerShell all of this different activity. Quite a lot. And in particular, we want to be looking for DNS names, right? Great way to find DNS indicators from live malware, right? Rather than having to like reverse engineer this and find obfuscated stuff, DNS don't lie. So the second that you're getting these DNS connections, and remember, this has totally hijacked my network stack, right? Such that traffic is not getting out. If I run something like ping google.com, notice I'm seeing the DNS query and I'm getting a reply from localhost because everything is getting looped. So FakeNet is a really quick and easy way of redirecting your network traffic on a Windows machine. There's iNetSim on Linux, which is also super handy, but for Windows, this is about as good as I've found. If we look at the FakeNet help, it'll also tell you that there's a config file. Trying to find where it tells you where the config file is. Theo and D-Word, thank you so much for the follows. FakeNet config file as in the same directory as the executable. Ah, very good. So if we go to chocolatey. Oh god, note to self, give your machine more than 2 processors and 4 gigs of RAM. You can add a fakenet.cfg in here, and let's see if we can find a fakenet.cfg example. Yeah, this is it's an archive, or it's not archived, but it's no longer updated, but it still works great. Configs. No. This is the default.ini. Yes. So this is kind of what the config looks like, right? Debug level, flush IP tables, DNS server. So you can configure what it looks like if you want to. All right, now, once we kill this thing, my experience is that it doesn't bring the internet back. Right? It's still kind of broken. And a couple ways to solve this problem. Obviously, rebooting the machine would do fine. If you don't feel like rebooting the machine, I've also found that in Proxmox, if you simply disconnect the interface and let Windows figure out that it's unplugged from the internet, right? And then reconnect. We're back in business. So, if you don't feel like rebooting the machine after you do a fake nut run, just literally unplug it and plug it back in. We'll do the job for you. All right. So, we're pretty much up, and we have, win analysis. I do want to make sure that remote is available, though, for these machines, because it's going to be a pain if we don't. So now you might think, why aren't we using Windows 11? And the answer is because it's a huge pain. I have not successfully installed Windows 11 on Proxmox yet. I know that theoretically you can. Proxmox has a TPM 2.0 capability, but I have not been able to make it work. And I don't know if that's because of the storage drivers or what. Although it seems to install fine, it just doesn't boot. I really don't know what the issue is. All right. Now let's see if we can connect to analysis. I like 1440 by 900 because it's enough space to do work, but it's not so big that I lose my interface. There we go. There we go. That's what you want. Okay. So obviously we have a cutter shortcut, but we also have PE Bear and all sorts of other stuff. So, you know, I probably should have installed Brave, but Edge will do fine. All right, so let's go get some samples. Let's go to... Oh, man, you know what I should have installed? I'm going to add this right now, actually, to the playbook. Is 7-zip. But the good news is I still have Chocolatey, right? So I can do SSH, malware lab, win, analysis. And I will do path plus equals C. Nope. Program data. Chocolatey bin. And we do Choco. What? Oh, come on. That was dumb. Path env. Or no, other way. All caps path. Oh, did I have it right? I had it right the first time. What the hell? Env path. I can't believe I got that wrong. Ugh. Okay, now Choco install 7-zip. There we go. Was it 7-zip without the dash? Yep. No dash for 7-zip. Gotta love command line package managers. All right. Dark mode, please and thank you. Not that it's going to matter much, but we're going to go to abuse.ch. And we'll take a look at, the Malware Bazaar. So let's go to the Malware Bazaar database. I am not a robot. As far as I know. No bicycles there. That doesn't seem like a very bicycle-friendly intersection. Okay, so the latest and greatest, we've got some Redline Stealer, some Smoke Loader. Ooh, Smoke Loader might be interesting, because that's been cool recently. Agent Tesla, as always. If we want to look for ransomware, we can definitely do that. Nope. Oh my god. The delay on the clicks is killing me. Why is that? Why are you doing that? Stop that. I'm blaming Edge for that one. That's how you search stuff in the Malware Bazaar. Medusa Locker. Interesting. That's from today, too. Let's go for this one. All right. I will download the sample. And we'll likely want to turn Defender off. Yeah. Because it's not going to like that. So off you go. Windows Defender, thank you very much. Let's try that again. All right, file is downloaded. We'll do some static analysis on this first, which will be nice and safe, or safe-ish. We'll also make sure that we compare our findings to what else is there. I really like the... But why? I really like the hatching triage reports whenever they're available. And indeed, this one is. So we'll take a look at the hatching triage report here. Toxic Monster, good to see you. So just to give us an idea of what they found. So static, there were some signatures that it detected, but I'm not interested in static like this, right? I don't care about hashes. I care about what it found in its execution. Now, it looks like this one didn't work out so well, and we don't have any kind of findings here. So this is one of the things that you'll sometimes find in these sandboxes, right? That the samples may not work, or something happened in the sandbox run. So even though there were static detections, I'm much more interested in behavioral information than static detections. So I want to know what the malware does, and at the moment, I don't have any ideas because this thing didn't execute. So what we're going to do is we're going to extract this thing, hopefully with 7-zip, if it installed correctly. I'll just go get a sandwich while my right click responds. Yeah, there it is. Okay, 7-zip. And then we're going to extract here. It's going to ask for a password. Same as the VX Underground password, which I can't tell you. And we're going to right away, let's make sure that view file name extensions is available. Okay. And we're going to right away defang this thing. Right away. Gambit and Theo, thank you so much for the follows. Okay, so we have some tools. Let's go get them. For those of you who just joined us, what we're doing is we're doing some malware analysis in a lab that we created ourselves inside of Proxmox. So I'm going to go to C and program data. And honestly, I should add a shortcut to the desktop for this. By the way, be aware that program data doesn't show up by default. It's hidden, but it's there. Chocolatey. Bin. Didn't know Ansible works on Windows. Yeah, so Doomer, the way this works is that as of like 2 years ago, SSH is first party. OpenSSH is first party available in Windows 10 and above. And so there are plenty of Windows packages. You could actually set up Ansible to work over WinRM, but if you set it up to work over SSH, it's so easy. And that's what we've done. So yeah, we just configure the machines to have SSH available, and then we connect the same way we do to our Linux hosts. Easy deal. Notice that all of our sysinternal stuff is in here, ready to go, right? But we also, of course, have PE Bear and we have PE Studio. So PE Bear and PE Studio are going to be kind of my first moves with any static analysis. So I'll open both of these up. There it is. There's PE Bear. Let's load PEs. We'll go to downloads and grab this guy. Oh, interesting. This is not supported file type, MZ. Yet it absolutely, we believe it to be an executable. So that's really interesting, right? It doesn't, I mean, it was considered an application, but there was something up with it. Let's take a look at PE Studio, see what it can tell us. Why is PE Studio not opening? Oh, there it is. Fantastic. Okay, so PE Studio. Show me something. Here we go. So it does show us MZ, which would be what we would expect for a Windows portable executable. It's doing some work on indicators. It's looking to see if it's on VirusTotal, which we know it's going to be. All right, it already found that it's identified as Medusa Locker. Neutral Hazard, thank you so much for the follow. And Good Humanity, love that name. We have some strings coming in. Always interesting to see. Yeah, it is a newish sample. It was just submitted today. And we've got indicators coming in as well. This is doing a lot of work for us, and this is why I like PE Studio as a first pass, because it'll tell us a little bit more about a sample without us having to work too hard. It's nice as a static analysis tool. How big is this sample anyway? 655 KB. Okay. All right, while that's baking, I'm going to grab the same. And we're going to go over to the victim. And I'm going to set up remote desktop here as well. I don't know why it was being such a jerk before, but yeah, it's on. What? What? Okay. New connection. SecLab at malware win victim. Did I type the password incorrectly, maybe? Nope, it's working now. By the way, this application KRDC is one of my big reasons why I like using Plasma KDE Neon as my base jump box, because it's a really nice RDP client. Okay. Before we do anything else. Snapshots. 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 Call it pre-malware. For whatever reason, snapshot names can't have dashes. So we're just gonna save our game here before we do anything spicy. Now we're also gonna do the Choco. Oh, it's paused execution, so I'll have to wait for just a moment for that to happen. There we go. Almost done. Right, it's saving its RAM state is part of why this is taking a second. You see we lost the RDP connection because it paused for a moment. We'll make sure this thing has 7-zip as well. All right, snapshot taken. Let's get our victim back. Should be able to reconnect to that with little difficulty. And now that I have a RDP connection that has a proper clipboard, or does it? There we go. Now I can go download this sample on the victim. I am not a robot. It still thinks that I'm a robot. It might know something that I don't. I could be a Nexus 6. All right, same deal. We're going to download the sample. Oh, wait. Defender also needs to turn off here. Which is a thing we can do programmatically. And probably should, so that's a good note. But sometimes you want to see what Defender can catch. Alrighty. Let's look at the folder location. Did I give the victim more power? It's much more responsive. Nope. Exact same. That's so funny. It might not be indexing the same way. $110 maybe. Ishel, thank you so much for the follow. Sorry if I massacred that name. Let's extract the files. Okay. And again, we can take another snapshot if we want, but honestly, it's fine right now. Now we have some choices. Do we want to just let this thing run and collect logging data through our SIM? Do we want to see it happen with FakeNet first to collect indicators to see what it does? We have some options. I always like running it. If I'm going to detonate malware, I always like running it in a network isolated environment first to see what it does before letting it have any access to anything else. So that's going to be my first move. And so we are going to turn on FakeNet. And as an additional safety precaution, we're going to add some firewall rules as well. So we know that we're going to block HTTPS and DNS, all that stuff. We're also going to block outbound. We're going to drop SMB. And we're going to log that, actually. So if it starts doing SMB stuff, we'll know about it. Have I ever used Norabin for malware analysis? I have not. I do not know what that is. Ah, I see. A portable, simple malware analysis sandbox. Python-based. I see. Yeah, I've used Cuckoo, which is a similar concept. I kind of like doing these things hands-on a little bit more. Cuckoo also, I don't love the way that it interacts with hypervisors so much. The truth of the matter is that if I have something sensitive enough that I don't want to give it to hatching triage, odds are there are some things that I want to take a look at with it anyway. It might be something to explore, though. It does seem a little bit lighter than copyright 2015. It's still updated. They might want to update that copyright. Okay. So we're going to enable FakeNet on our victim here. We've denied outbound SMB. And we'll make a file in here just to give it something to, if victim, and let's put some text in here just to see what happens. All right, let's see what happens. Fascinating. This app can't run on your PC. To find a version for your PC, check with the software publisher. Why not? What is this thing? Is it wholly defanged? I mean, I saw it was missing some headers. That's so interesting. I'm wondering if the actual sample was defanged in a way that prevented us from taking a look at it. Which, if so, we'll go grab another sample. That's easy enough. Let's try something that actually will get us. And maybe something from not this person. This capital R ransomware might be not the tag I want. Lowercase r, please. Why can I not type? Hey, Oreo. There we go. Same deal. All of these are being reported by the same person. I kind of don't want that to be true. Let's look for another Medusa Locker sample without it being tagged as ransomware. There we go. Well, these are a lot older. Let's see what's new. Maybe not just Medusa Locker. And we had the smoke loader. That was interesting. And Redline Stealer. Let's take a look at this smoke loader. Okay. So again, we're going to grab that from our victim here. Yes, we are downloading malware. We're doing so in a safe way. That's the whole point of this lab. Okay, so we're going to download this sample, but we also want to see if it has any... Oh, Hatching Triage is calling it Vidar, which is interesting. Oh, and it has behavioral reports too. That's great. That's a great sign. The sample is going to do what we want it to do. Okay. All right. So downloaded this thing. This is the 2BD. We'll clear out the E89 because it's nothing. Extract this here. Again, we're going to do the static analysis first. Ooh, it has an icon and everything. Look at that. Fun. Okay, so again, we're going to defang it. Okay, and then we are going to fire up. Let's start again with PE Studio. What does it mean to defang? So a defang is a way of preventing accidental detonation or accidental execution of the sample. So, Christy, you're right. If we're talking about URLs, it would mean mutating the URL to add brackets around dots. IP addresses, domain names, same thing. That's what defanging means in that context. In the context of an executable like this, we're changing the file extension so that Windows doesn't automatically try to load it as an executable. Okay? So we don't want to accidentally set this thing off. All right, so PE Studio is doing a lot more with this sample. Good times. Let's get it going on our victim machine as well. And again, we're going to 7-zip, extract here. Now, on this machine, this is our victim. We are not defanging it. Okay. That's weird. That's weird. Looked like FakeNet didn't prevent the... Yes, I have 2 VMs, one for analyzing, one for executing, and actually I have a third one, Bonobo, that is pulling in data from our machines. We have a SIM here. So if we look at our agents, even though they both have the same host name, they actually have data that will be coming in. Right? So if I look at our alerts in security, I don't have any of the rules enabled. I should probably do that. All right, we'll leave it in. We'll leave the alerts off for right now. We'll stay in Discover. Why? Why are we not getting data? Interesting. Okay, I don't want to spend time troubleshooting this right now. If we have to modify the ELK stack, that's okay. But for right now, I want to see what we can see. We have a lot of tools, actually, to look at this thing even without this. Like, we'll have sysmon logs and such. So for our victim here, we can fire that off and take a look at some things. But also, let's see what our static analysis says about this sample. We have 51 indicators. We have URL patterns, so these might be IP addresses that it's going to try to connect to. Although, they seem a little bit funky. We have debug symbols. David, this is not the cloud. This is my machine. It's a server in the other room. So it's a hypervisor, yes, but it is not somebody else's computer. It's my computer. No, this is not AWS. This is Proxmox. This is where everything is running here. All right. Written in C++, looks like. We have the PDB file. I don't think it was actually stored. Or was it? Here are the functions that it's using. Set volume mount point. That's interesting. Emily, thank you so much for the follow. That's really, really neat. We're mounting volumes. Perhaps for shadow volumes or something like that. Virtual protect. Read file. Get command line. Pretty common stuff. These are all Windows API functions coming from kernel 32, right? We're just seeing kind of what has been imported here and is getting called. TLS. So TLS get value, TLS elect, TLS set value, TLS free. This is communication. Yeah, interesting. Strings, what do we have? Okay. While we're waiting for the strings to figure themselves out, let's see what PE Bear has to say. This is another really great tool. And I do want to show it off, so we'll... I didn't need 2 instances. File load PEs, that's what I wanted. And we'll go into our downloads. Right here. Wonderful. So one of the things with the Malware Bazaar is that there can be garbage that is submitted to it. There is a dark mode, in case you were worried. So PE Bear is pretty awesome. Take a look at what we're getting here. Not only does it have a hex view with ASCII decoding, but it'll also give us the sections. It does disassembly the same way the Cutter does. Right, gives us general information. Gives us the DOS header, rich header information. All right, so we can see that it's from Visual Studio. Pretty cool. Here are our imports. This is the same stuff the PE Studio was telling us, but we're seeing it in a different way. These are the DLLs that it's talking to. Kernel 32. GDI 32 is interesting. GDI 32 indicates that there's some sort of graphical component, that there's a window that will be opened. That is surprising. And add VAPI. We can see the debug information. It was made Saturday, the 24th of September, 2022. And at C/Karuhu/Dan, and then this is what it was used to compile, is the debug symbols. So pretty cool, I think. PE Bear gives us a lot of information quickly. Oh, thanks, Foot. Good call. And if we go back over to PE Studio, it's loaded some strings for us. A lot of them are the function names. And then below that, there's garbage, right? Yeah, definitely way to flex those, add those mod powers. All right, these are things that we would expect to see in a Visual C++ program. Some date stuff. Nothing particularly wild here. If we wanted to, we could filter this a little bit. And this is, again, why strings is nice, or floss might be good to extract more reasonable strings, right? If we were looking for them. The truth, though, is that strings has become less and less useful for these kinds of samples just because of the obfuscations that are easy to do now. It's always worth a check, but don't be surprised if you're not going to find a lot of stuff in there. Now, this has 34 detections on virus total. Toei Hoshi, thank you so much for the follow. Arigato gozaimasu. And man, these are all over the map. Some of these are just kind of generic, suspicious PE variants. Sabsic from Defender, calling it a Trojan. It's a downloader agent. Azeralt. WinMalware.Azeralt. Yeah, these signatures are all over the place. That is super interesting. Okay. I really wish. I don't know why the malware, the ELK stack is not giving me data. Like, at all. I mean, I should be getting it at least from the system. You know what I mean? The service is absolutely running, but let's check. Yeah, but we will restart it. See if that does any better for us. Because again, the data is going in, right? We know that we have the fleet server working. All right, we'll give that a minute. I think that's worth waiting for if we can get the service up and running. It would be nice to see those logs. Okay, Elasticsearch has been restarted. Yeah. Here we go. Still nothing. If we go to our fleet, though, we still have our machines. We go to the agent dashboard, what happens? Okay. Yeah, it's not picking up the data. That's different. Nope, no firewalls. Nothing internal is preventing this from happening. And again, logs should show data directly from this agent. You know what? When in doubt, we're going to reboot the whole machine. See what happens. I may have to change something about how the playbook sets this up. Do you need to create the index or something? No, I shouldn't have to do that because setting up the fleet server and everything will handle that for me, and setting up Kibana will do that for me. I shouldn't have to do anything, and the enrollment stuff is done as well. So again, should not have to make that happen. That's actually why I didn't automate the whole process, just to make sure that the enrollment worked the way that it was supposed to. One thing I do need to do, no, because outbound on 5601 is still allowed, or whatever. Yeah, that's still allowed from our victim. But the win analysis machine should also be coming in, and nothing is blocked there. If we look at our services running on this machine, we'll see that the Elastic agent is running. Yep, everything's good there. Okay, that's up. Ooh, interesting. Oh, did the IP address change? It better not have. No. 58. There we go. It's back up. Okay. Kibana server's not ready, so we're going to give it a second. We may... You know what? I've had this happen before. This is something crazy about ELK I found, that if you restart the machine, sometimes... Well, apparently not this time. You have to independently restart Kibana. That looks okay, though. Uh-huh. Nothing at all. And no metrics data either. So that's... Something's messed up here. Yeah, my user is a super user. Yeah, nothing in there, though. Pretty wild. Okay. I'll have to do a little bit more investigation as to why this is not playing ball. Every single one of these should be working out okay. For now, though, let's go ahead and see what this thing does. So again, we're going to turn on FakeNet. Okay, DNS, SSL, 48443. This is good. All right. Now this is default stuff, right? SSL. If I wanted to do a default block, what I would do is go to Starbase, go to my victim machine, right? The first thing I'm going to do is set up a firewall rule for outbound, except no, because we have RDP in already. So actually, if we want to drop everything else outbound, then we can do that. Right? This will stop all other traffic from coming out, and we'll do warning logs for this. Oh, wait. Nope. Not accept. I want the other thing. I want it to be a drop. Okay. So now, just to prove a point here. Well, that's replying from, that was dumb, because it's, you know, it's already routed through FakeNet. All right, so let's fire this off and see what happens. Oh no, this is the wrong one. I want 2BD. There we go. Let's take the victim text file and toss it in here. Okay. See what happens. Now again, don't forget, we still have Sysmon running, so we can review the logs just fine. And indeed we shall. What does FakeNet tell us is happening? Some Microsoft stuff. Config, Edge, Skype. Nothing interesting there. Receive new connection. Received unsupported HTTP request. Okay. We're not seeing any crazy DNS requests, though. Right? These are all from Microsoft, so we would expect those to be taking place. Now, it's entirely possible that there is some check-in here to prevent the application from running. But don't forget that we have some other tools. We have Procmon. Now, there are some malware samples that will actually look for Procmon running or other tools like it and kill themselves. But we're going to hope that's not the case for this thing. I'm going to copy that as a path. And we're going to use a filter here in Procmon. For the process name contains okay, add that. What you got for me? Nothing at all. Let's run it one more time, see if anything else happens. Aha! Here we go. So look at this. We have lots of good stuff from Procmon. Thank you, Procmon, for being you. Look at all this cool stuff that we're getting. So, loading NTDLL, which we would expect. Because of the late join, do I expect DNS? Do you mean poisoning? No. I don't expect DNS poisoning. But all right, let's see if our firewall logs are picking up anything. Because remember, we did an outbound. Look at this! So much good stuff. God, I love the firewall. Now, some of this might be garbage. No. 10.1.98.188. $9,200. That's the Elastic Agent, actually, is what that is. That's the Elastic Agent, port 9200. Yeah. So that's a good one to actually add. Out, accept, dest port 9200. Yeah. Yeah, that stopped that right away. Okay. But let's get back to Procmon here. Plenty of stuff happening. So it's loading some DLLs. Lots of registry stuff that it's opening, which... it's opening language sets. That's a common technique, right? We would expect something that is regionally locked to look for the languages that are installed and enabled. And if something like the Russian language pack was installed, it would die. So that's a pretty common one. As a matter of fact, it's not the worst mitigation to install the Russian language pack, just to stop some of those. So a lot of registry reading. Preferred UI languages, again, it's looking for those. It downloaded a DLL. Or it created a DLL, I should say. Query open. Oh, it's looking everywhere. My bad. No, it's not. It's looking for MS VCR, the Visual C runtime. That might be why it's not running. Yeah, thread exit. Aha. Interesting. Tom Berry, thank you so much for the follow. So, what happened here? Essentially, the machine, so the application looked for the Visual C runtime, could not find it, and therefore died. Is basically what happened. Which is something to think about, right? If it doesn't have the ability. Oh, that's funny. Look that it looked in chocolatey because it's part of our path, right? For that DLL. So again, very interesting. If we wanted to see this happen, the less libraries you have, the less likely the virus can work. I mean, yeah, if you write this thing and it has a dependency for Visual, if you write this thing in Visual Studio and it has that dependency, it's very likely that it will have some kind of failure modes. Now we can install the Visual C runtime. That's not impossible. Let's kill FakeNet and let's reset our network interface so that we're able to work again. We just unplug. Well, you know what? Actually, let's do it the right way. Because we don't know what else happened, right? So we'll restore back to... Yeah. We'll restore back to our safe Are we sure the virus is dead? Yeah, we didn't see any create threads, and we didn't see anything else, and we certainly didn't see any file writes. It was a check, and then it died. We saw the thread exit. So in terms of confidence, high, but we are going to reset back to the known good configuration and go from there. Yep, the snapshot before the virus was installed. That's right. Okay. Yeah, that window died. We'll have to wait for that SSH connection to end. So let's actually go get... I'm pretty sure that it was... Oh, very funny. Oh, I forgot to reconnect the network interface. I was doing two things at once. Oh no, it should be connected. FakeNet was running, now it's not. That's probably the issue. We just lost the connection to it again. Come on, yes I am. I wonder if FakeNet is still running. No, I'm just being goofy. Right. How about we disable that? Much better. I was too locked down. Well, better safe than sorry. Yeah. C++ 2010. Let's go get that. Any reason why Proxmox over VirtualBox or VMware or whatever? They are different. They are different. Maître Bonobo. So let's quickly talk about the difference between Type 1 and Type 2 hypervisors. Type 1 hypervisors are right next to the metal. There is no ambiguation. There's no abstraction between the hardware and the thing that's doing the virtualization. That is what VMware ESXi does, or vCenter, right? That is what Hyper-V does, actually, because it has access to the kernel. VirtualBox and VMware Workstation are what are known as Type 2 hypervisors, which means that there's an intermediary between that hypervisor, the operating system, and then the virtual machine, right? They tend to be less performant. No, they are less performant. And that is not what I wanted. So I have a whole server set up that's doing all of my virtualization. So there's no reason for me to use VirtualBox there. I'm using a Type 1 hypervisor that manages my VMs. Let's go get this thing. It's funny that you have to do this before you can even run the... type 1 doesn't mean that there's no OS. Type 1 means that there's no OS between the hypervisor and the virtualization, meaning that it's essentially direct connection to the metal. Proxmox is an operating system. It's built on top of Debian. But consider the difference between that and what VirtualBox is doing. So VirtualBox has a virtualization layer that is working with Windows, and then you have the VM. So there's this extra layer between the hypervisor and the VM itself, and that adds complexity and kills some performance. That is the difference. Okay. You're very welcome. Another thing I love about KDE is I've got this clipboard history that's really easy, so I can go get this payload again. This still has to figure out that it's a broken pipe, though, unfortunately. Now explain how WSL is different. I can, though. I will explain that Windows Subsystem for Linux is in fact running under a Type 1 hypervisor, because Windows Subsystem for Linux version 2, at least, version 2, is a Hyper-V VM. It doesn't look like it, but it is under the hood. It's a Hyper-V VM. That's what's happening. And so Hyper-V, because it has access to the Windows kernel, it is in essence a Type 1 hypervisor. So when you set up WSL version 2, you're creating a VM in a Type 1 hypervisor. Windows Subsystem for Linux version 1 is in a lot of ways technically a lot more interesting. Hey, Asti. Good to see you. In a lot of ways, it's more interesting from a technical perspective, because there were all these crazy hacks that they used to get essentially the Linux kernel to interface with the Windows file system. And also, I will say from a security perspective, actually V1 was safer because your security tools could see the Linux file system, right? Because it was just it was a directory in Windows. But in WSL version 2, it's a VM. It's totally isolated from the security tools that you would put on, so Windows Defender can't see it. I'll give you a great example. If on WSL version 1, if you installed Kali from the Windows Store and you had EDR products like CrowdStrike or SentinelOne or a Cisco AMP or whatever, if you had those enabled, they would light up like Christmas the second you installed that, because it's like all of these tools in Kali just showed up on the Windows file system, right? Like, what are you doing with the Metasploit framework? If you install version 2, they are not going to make any noise at all. I mean, custom detections might do it, but the signature-based stuff isn't going to do it. And sometimes the custom detections are funky too. I've seen really funny alerts for things like DNS cat or something like that, when it's literally just the Kali VHDX. It's like, I don't think you got that one right. Okay, let's install. Okay, that's done. Now, again, something very handy. Let's make sure Defender is off. Nope, wrong thing. Manage settings. Off. Off. And off. Great, thank you. And now we will go to our malware payload to get it back. That's the E89, this is the 2B. I actually have it still in my clipboard history. That makes it way easy to just go get this again. Don't be surprised that Windows Defender is doing a good job. It is actually, especially for the price, phenomenal at what it does. And Defender for Endpoint is also quite good. It used to be a joke. It's really not anymore. Hey, Don3131, or 313L, thank you so much for the follow. And, boy, man, these names, 6v10, FYMMC, thank you for the follow. Let's get this sample again. All right. And see if this does any differently this time. So we will look at this in the folder. We'll also get Procmon up and running so we can see this thing. We'll add a filter for the path contains. What is it that I'm doing, Omni? I am detonating malware in a safe lab of our design using a virtual environment known as Proxmox. Okay, now that we have this DLL, I have some reason to believe that this will go a little bit differently. All right, so again, we have the sample. We have Procmon up and ready to go. Still don't know what's going on with the ELK stack. I'm going to have to troubleshoot that a little bit more. But for now, we also have to set up FakeNet. We want FakeNet running. Okay, so we're going to pick up some of those DNS queries, and then we're going to turn this outbound drop rule just to prevent anything else goofy from happening. And now our lab is fully set up and ready to detonate some malware. Let's go. All right, Procmon. Okay. All right, here we go. 1,266, 293. It's still running. Where fault got injected. That's very funny. Yeah, the malware's working. It injected task. It looks like it might have injected Task Manager. Let's see if we can see that DLL search. A lot of files getting created. Oh yeah, look at all these other exes that are getting created. Yeah, this is the good stuff. Okay. Setting up all of these. Process create. You love to see it. Sysmon's showing it to us. Can you see the process running in Task Manager? Almost certainly. let's hold on a second before we do that. Let's see if we get anything from FakeNet. Nothing yet. This might be the final move, right? This might be just the ransomware detonator, so not so much with the network executions. Still going, though. Where fault is interesting. SVC host. Lockdown file. Yeah, the ransomware is executing. Oh, show. That's really funny. Could also have had TCP view up. Yeah. Hold on. I only want to see I want to take off the version 6s. Thank you very much. Cool. We could also do a packet capture if we see some interesting network traffic. And let's see. Anything else cool in Procmon? No. But then again, we're only looking for things that were from that specific binary. Now, if we look at, let's go to our win analysis. If we go to the hatching triage, what are some things that we would expect to see from here? Finally, notice that we have some detections. These are behavioral detections. So what are some things that we would expect? First of all, a ransom note, and .toz, some C2 from winline.com/lancer/get.php. So what are some other behavioral things that we would expect to see here? Because this is a general report. Files. Right? It's creating this app data local temp file.exe. Okay. Now, it's possible that allowing or preventing that call out to the network stop that from happening, which is why you got to kind of try it both ways. What is the most common way to deploy the sandbox environment in a SOC? Usually people pay for it. But I think, yeah, probably VMware is the most common if you're going to do your own, because that's what people pay for. But I like Proxmox a lot. So there's a lot of stuff that gets created in app data. So let's go take a look at app data just to see if there's anything going on there. We'll just do it with Explorer real quick. Okay. Anything fun in temp? No, doesn't look like it. By the way, yeah, that was the thing, Sin. Thank you. I was pretty happy with how this worked. Data. Let's look at roaming, see if there's anything fun in here. Nope. I have a suspicion that the original... Oh, I should mention, whenever you look at the network tab in Hatching Triage or any of these, it's every network connection that happened during the execution, not the stuff that's bad. It's everything. So obviously quad 8s, that's not bad. It's from service host. That's fine. So you got to see what process did it. And even then, you might not be sure. So the network tab actually is usually kind of useless here. You want to go for the report to see what it found. Right, now this is HTTP, which is interesting, right? It also, let's see if there are any mutexes. That might be interesting too. What are mutexes? Glad you asked. Mutexes, or mutually exclusives, are ways that the malware can use to prevent duplicate execution. All right, some of these look like they probably were from our malware here. Primed Banana, thank you for the follow. Okay. I'm not seeing a lot of... I mean, I didn't give it a whole lot of files to encrypt here. But I do think that it may have... Wait, this is the victim. Yeah, I have a feeling that even though it was running, right, it went to were fault, and I think that it may have... I mean, hold on a second. It's not that it crashed, it's that it did its thing, right? So we're now learning that it has safeties. So here we go. The first thing that this thing did, right, was the load image. Looks for compatibility, looks for registry. This entire stream was about how we make a custom Windows VM for malware analysis. I encourage you to go back and take a look. Okay. Oh, wow. So let's see. Yeah, this is the entire executable. So create file, but what? Can I see the properties of this event? Operation create file, path was just that. Okay. And then What do we see? War fault. SVC host. I am not convinced that this thing executed the way that we would expect. And at this point, what I want to do is I want to try knock off the outbound here. And clear. Yes, I was still running FakeNet. I was. And that was intentional. Now, in this case, we're going to kill FakeNet. Oh, actually. So I want to try packet capture, but I want to try packet capture a different way. Yeah, I'm curious to see if this thing has some VM detection too. I don't think it does, because I didn't see it enumerate any registry stuff for like CPU cores, or I guess that's not registry. It might, although we didn't even see those functions come in the imports. There may be something that we're missing. It's entirely possible. Now, I will say this. One of the things that I did specifically for this VM was I gave it a little bit more horsepower, right? So it doesn't have a single CPU core, which is one of the ways that you'll often see checks for this. So the last thing I do want to try, and then I think we'll call it a day, is I'm going to disconnect and reconnect the network here so that, no, I don't want to do that. Actually would very much like my internet to just work. Of course, FakeNet absolutely just ruins my network settings, which is annoying. Okay, it is what it is. Let me exit my SSH connection first then. And now we will disconnect and reconnect the hardware. Okay. I didn't even lose my RDP connection. That's cool. Let's get our SSH back. Now, did you know that Windows has a built-in packet capture tool? It does. You don't even need Wireshark, because PKTmon exists, and we can use it. Yeah. I had a pretty good numbers tweet about this the other day, because apparently nobody knows that this exists. Oh my god, everybody is like, what? Is that new? Not really, although it was added, this article was written in May. So check this out. The first thing you need to do is configure it. And it says Packet Monitor can convert logs to PCAP-NG format. So we will actually install Wireshark so we can read the thing. That's a good one to actually install. But yeah, so PKTmon allows you to set up not just a packet capture, but, yeah, let's go to packet capture command formatting, but you can filter it too. So we can do filter add, and then stop, and then get the packet captures. So the filters can be like add IP address here, and like protocol, or add 53. So you can use these kinds of filters, and then all you do is do like pktmon start. And that's kind of it. Now, if you want it out, right, you can do pktmon counter. Once this is installed, right, so we'll do pktmon help, which will say, so look, there's etl1l2, convert log file to text format. If we look at the packet filter, we're not going to do any packet filters because we don't need to at the moment. We're just going to capture everything. Let's set pktmon counters to see what's all counters are 0 because we haven't started any packet captures, right? That's kind of it. We do pktmon filter, we'll see what filters there are. So pktmon filter list. No filters. So that's fine, right? So we could do filter add type TCP if we just want TCP connections. And now that's it. And then we do pktmon start. Ooh. What was it? Start -- capture, right? -- capture. If we want to see start help, it should tell us what our options are. There we go. So -C for capture. And select all components to capture packets on. Can be default is all, which is fine. And that's it. So we're going to pktmon start -C. We're now capturing packets without using Wireshark. Let's go execute our malware. Let's see what we get. Oh boy. All right, where fault is coming in again. Ooh, that's new. We got a new service called BAM. Oh yeah. This thing is gonna wreck our day. Did TCB view capture anything? Yeah, now the virus has the access to the internet. This thing's new enough that I would imagine that it's down, although since the indicators were already up. Compatibility assistant. Yeah, interesting. We see some remote addresses that are a little funky from service hosts too. Wherefault is the built-in Windows error reporting tool, but here's the thing: because Wherefault has an exclusion from Defender, it is often a thing that people will use, or attackers will use to inject into. Oh yeah, definitely seeing some stuff going on here. 1364.180.106. The hell is that? 1364.180.106. Who is 13. Do I not have who is on here? 13.64. .180.106. Oh, that is Microsoft. Okay. But it could be, here's the thing, it could be Azure. It's the thing that's a little bit annoying. Okay. Let's see. Let's take a look at our services here. Get service. I think we saw one come in that's a little bit funny. Azure is Microsoft. I mean, something is using Azure. Like if they set up their attack using an Azure VM, it'll still show as a Microsoft IP. Okay. Tell you what, let's do pkdaemon stop. Okay. Now we got a log file, seclab pkdaemon etl, right? And now, check this out, pkdaemon etl to pcap. What was the name of this file? pkdaemon etl, right? So etl to pcap. Oh, it made the pcap for me already? Thanks, pkdaemon. Way to be a buddy. How handy is that? And I already have Wireshark installed, so I can read this pretty easily. See if anything interesting happened. Hey, Volley. Good to see you. So we see some DNS stuff. Oh, I see some application data down here. It's TCP. Some HTTP. Let's look for all the HTTP traffic, because we know that that was one of the indicators. I mean, you could have just run Wireshark from the start and avoided all of this. That wasn't the point. I think that FakeNet still has our stuff broken. Is what I think. Because I'm still getting responses there. That's really funny. Is this the right thing, though? No, this is the wrong, yeah. This is the wrong thing. Okay, I should have done what I thought I was going to do, which is pkdaemon etl to pcap pkdaemon.etl. That should be, yeah, because this should make a pcap ng. There we go. That's a little bit saner. Yeah, I forgot that FakeNet's going to do a pcap for us as well. Take your time. Okay, that's a much chunkier packet capture. That's more encouraging. From a red team perspective, it's pretty good because if you want to use lolbits. Oh man, yeah. So Vale, I have a whole plan to involve PKT because, by the way, there's the PKTmon driver. You can use in addition to just the command line, so you can like hit up that DLL and just start using the packet capture capability without ever running the shell command. There's a lot of retransmissions, SSH stuff. I don't care about that. 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 I care about, let's see. Do we have any HTTP traffic? We do. Interesting. Let's follow this HTTP stream. This actually looks right. It's funny that we're getting so many retransmits, though. Whoa. All right. Sorry. I forgot how Wireshark works for a second. Let's take a look at conversations. See if we can identify anything that we don't know. So we've got quad 8s, of course. We've got DNS queries. 13.107.4.50, 13.64, 204.79.197.200, and 20.190.151.32. And 13.107.42.16. These are our conversations. And if we look at the bytes transferred, so 115K to 20.190.151.132. I'm almost certain these are all Microsoft, but let's see. Who is 20.190.151.132? Yeah, Microsoft. 204.79.197.200, which apparently I've done before. Also Microsoft. The 13s, 13.107.42.16, also Microsoft. But that's not a guarantee that they're, again, as I said, that's not a guarantee that they're okay. Okay, so who's talking over port 80? Here we go. 13.107.4.50. I'm going to apply that as a filter. Selected A to B. Okay. That's definitely just Microsoft stuff. Any HTTP objects to be discovered? I doubt it. No. Okay. So, a couple of things could have gone wrong here. First of all, we could have hit up a ransomware with a dead callback, right? Meaning that whatever we were looking at before, or whatever had been reported before, now that it's been reported, it's been taken offline. So this thing is essentially defanged itself. That's possible. Other possibilities would be that there are some detections that we haven't seen inside of this to see exactly how it goes, to prevent us doing exactly what we're trying to do. The very last thing I will show, I'm not at all good at this, and this is something for me to get better at, is live debugging. And so we do have Win64DBG on this machine. And so one thing we could try to do or X64DBG, I should say. Although, is it 32-bit or 64? I think it's actually, this is a 32-bit application, now that I think about it. I don't know why I thought it was going to show me that. But PE Studio should. We can close TCP view and Procmon for the moment. Yeah, PE Studio will tell me. Close Wireshark. Close the browser. Save some RAM here. Notion feature wait. I'm just seeing that now, Volley. So you should know that there is some stuff planned for offensive Notion. Mostly that we're trying to transition it out of just using Notion. We're trying to make it so that you can configure the agent to work with any trusted site interface layer. And we're building a team server that will essentially connect also to that same trusted site channel and compile all that information. So you can manage multiple agents. You can also manage multiple channels. And we're also going to add an encryption feature that allows you to have a little bit more OPSEC when you're using trusted sites. So those are big, big lifts, but that's kind of where the project is going. Which yeah, it's a 32-bit. So we're going to use X32 DBG, not X64. Which is all the funnier because we actually finally got our feedback from DEF CON back as to why we were rejected from the talks. Now, maybe it should have been a Red Team Village rather than a main stage, but we were pretty excited about the material. But it was rejected on very funny grounds, because when we finally got the feedback, they were like, who cares? It's another C2 in Rust. You're not doing anything special. That's literally, those are direct quotes from the feedback. Like, this isn't interesting. We respectfully disagree. We did think it was interesting that we were using trusted sites as opposed to a standard C2 channel. But that's how that goes, I guess. Yeah, the tone of the feedback was exactly what you don't want to have, basically, in this community. It was extremely dismissive. Oh, and no, the thing that I think really did us in, beyond everything else, was that we had already open sourced the code. It turns out DEF CON Mainstage really cares about dropping new stuff there. They want unveilings. Whereas if you develop in the open, then you will be penalized, apparently, for that. because they want exclusives. Okay. So this is X32DBG. We're looking at the disassembly here. Some breakpoints. Look at the call stack here. Yeah. This is the part where I become the golden retriever and I don't know what I'm doing. Because, I mean, I can read this actually okay, but I don't know exactly yet where I want breakpoints to exist. You know what I mean? I kind of just want to see it happen. And there are some breakpoints set. So let's run this thing and see if we hit any built-in breakpoints. We may well. This may even have defenses against debuggers. Paused. Int3 breakpoint at entry breakpoint. So we hit that. So let's go to... not trace into. Execute till return, I guess is what I want. Yes. Okay, we hit a breakpoint here, or first chance exception. Exception access violation. And what are we in? We're on an access violation here. Interesting. We're just running into all these. First chance exception. Yeah, I don't know. I think we might have some defenses going on against debugging, but I cannot be certain of that. All right, so obviously we have some more to do, but I think the lab architecture is proving itself, with the exception of ELK. We got to figure out what's going on there. But to sum up here, what have we built? We've built a tool that, with Terraform and Ansible, that can spin up these machines and then allow you to configure them how you want with Ansible playbooks for win analysis, a victim machine, and then an ELK stack, and have all of those communicate together. And then we can use the Proxmox firewall to fully isolate the victim machine so that you don't have any questions about whether things can get out. I think that's really kind of a cool layer of this as well. Yeah, we do have some extra logging data here. But for now, I think we're going to shut this down. So the way that you end your session here, once you've finished your investigation and you're ready to kind of just bring things back to a ready state, if you want to bring down the entire lab, you can do tf destroy auto approve, and that will just remove these machines. Nice and clean, leaves only the fresh scent of pine. And then when you're ready to try again, you can bring the lab back up, redeploy. I will be doing some work to try to figure out what's up with ELK, see why that didn't work. And then that's it. Your lab is ready to go once more. So that's going to do it for today, I think. Been a long stream. But GoPro is streaming, so we are going to give him a raid. Thanks, everybody, for hanging out. I hope you learned something. I know that I did, and I know that I had a great time hanging out here with you. If you want to see the rest of the InfoSec streamers, go check out the hack list as always. I will be back on Wednesday doing some programming, 5 p.m. Pacific. But until next time, please be good to yourselves, be good to each other, and happy hacking. We'll see you next time.